SwayamPrabha. Digital India. Educated India.
Lecture number 37. This is related to dissemination of natural dyes. Now, what does the word dissemination mean? It means that having learnt the techniques and the nuances of natural dye and dyeing, how do we take it forward to the industry for commercialization? How do we show that the same existing infrastructure can be used for natural dyeing? Often those who have been using synthetic dyes have a mental block that they do not wish to switch over to natural dyes, because they think there are too many approximations required for natural dyes. And as we go along this lecture, you will see that the ease of natural dyeing is so convenient that one can practice it without having these mental blocks. It was considered that there are drawbacks with natural dyes, that there is color fastness issue, wash and light fastnesses, and we have shown through our research that how by the proper mordanting step or by the proper dye fixing step we have overcome the myth that was around natural dyes about the fastness property issues. We have improved the wash fastness and light fastnesses by using enzymes and rare earth metals. We have used plasma treatment and EB treatment, and without the use of mordant also we have attained better fastness properties. Color matching issues. Till the time there was no standardized method for natural dye, people were just mixing anything and everything and getting colored output. Well, that is good for hobby club, but that is not meant for actual dissemination of the dyeing technology. All the innovative technologies that we have developed, we are now ready for dissemination and giving away for commercial use. Batch to batch differences in color is no more happening. Why? Because standardized recipes have been developed for each of the dyes that we have worked on, and now it is ready for dissemination. Shelf life issues. If good dry powder can be obtained by spray drying, then there is no problem of shelf life issues. So, one has to remember that these natural dyes have to be handled a little more gently and carefully. And sourcing issue. Earlier people were thinking that if this dye is not available, then what do I do for red? For people who want red, they can use in the plains, they can use the tectona leaves instead of using madder, because madders grow at higher altitude. So, now what we are trying to promote, that locally grown flora should be explored. Waste from kitchen, waste from temple, waste from forest should be explored. How to combat these drawbacks? Batch to batch testing of dyes should be done. Standardized recipes should be followed. There won't be any change. Making quality checks at all levels of production, because if we are not quality conscious, then definitely we are not ready for dissemination, because in one batch there will be one product, in the other batch there will be either an inferior product or a superior product. Now, that kind of diversity is not allowed. Batch to batch matching is a must in industrial production. Process improvement to maintain the color. We have come a long way So many methods we have described of dyeing cotton, silk, wool, and not only that, we have shown jute and bamboo fabric along with polyester and nylon, and for each of these fabric we have made our own approximations to do better and best, save dyes from getting discolored. Now, in order to understand the cause of fading, remember we did a chapter on fading. If you understand the structural chemistry of the molecules which are colorant, then only you can come up with strategies to avoid fading, because photo fading is something which happens automatically. UV lights are very strong and they excite and discolor the dyes. So, how do we prevent? And all along we have been saying that when we are preparing dyed fabric with natural dyes, we have to dry them in air under shade and not under sunlight. Bring quality management system in practice. If we are practicing quality check at every stage, whether it is mordanting stage, whether it is the desizing stage or scouring stage, every stage we have to ensure that the fabric is getting better and better and more receptive to take natural dyes. If we keep all these points in mind, then definitely we can go ahead with dyeing with natural dyes, and this technology can be transferred to any and every dyer, be it a small dyer or be it a commercial dye house. Now, quality management, it is a completely different kind of management system where your knowledge of chemistry is not so much required as much as your quality consciousness is required. Quality management in any industry is a must and it ensures consistency. The four components of quality management are quality planning. Is there a need? Yes, there is a need. If we want to have quality product, quality planning is a must. Quality assurance. Can a customer be assured? Yes, if we are sure we are following the right method, we can give on the label the quality assurance. Quality control, can it be sustained? Yes, it can be sustained, because when we do a quality control at every step, we reject the faulty items, then the customer also builds a kind of a faith and the company gets a reputation of giving quality product. Quality improvement. Can improvement be done? Yes, from time to time the company has to engage in innovation and R&D to improve the quality and the designs of its products. Quality standards. The International Organization for Standards, that is ISO, created the Quality Management System QMS standards in 1987. It was certified organization in more than 175 countries to use it as standard. This standard provides a measurement framework for improved quality management, similar to and based upon the measurement framework for process assessment. Now, you will think, why are we talking so much about this when we are talking, this is a series of lectures on natural dye and innovation dyeing techniques. Why? Because at the end of the day, when we are talking about the dissemination of the technology, then we have to also look at the quality standard, because once it goes commercial, it needs to have a quality which will be liked by the consumer, which will be approved by the consumer. As long as you are doing small experimentations, you can afford to have variation, and nobody is going to check it, nobody is going to criticize. But the moment you are making products for commercial use, that time quality checks are very much important, and that is the principle that was acknowledged and felt that in 1987 175 countries came together to make quality management system. They realized the importance of quality management system. This standard provides a measurement framework for improved quality management similar to and based upon the measurement framework for process assessment. The quality management system standards created by ISO are meant to certify and the processes and the system of the organization, not the product or service itself. Quality standards for natural dyes. Therefore, we have to now concentrate, and that is the relation between the QMS. The QMS extends to natural dyes as well. Quality standards for natural dyes vary widely. So, it is necessary to first contact an importer to find out what they are looking for. The problem arises with standardization of color, as no two dye lots are appearing to be identical. Technicians in the pharmacology, food and textile industry loathe this lack of inconsistency. For attempting repeatability of shades for textile dyeing, the recommended procedure as mentioned in the recipe should be followed strictly. As I had been telling that when we were doing textile dyeing machine, everything should be made up of stainless steel. So, here also, whether it is a small beaker dyeing or a big commercial dyeing, all the dye bath have to be made up of stainless steel. The hardness or the water quality should not be more than 30 ppm, and the yarn water ratio should be 1:20, at least that is the minimum that can be taken care for natural dyes. When I started hunting for standards for natural dyes, I looked up at American standard, French standard, German standard, Spanish standard, British standard, even Bureau of Indian Standard, and there was no standard available for natural dyes. Now, why was I looking for standards for natural dyes? Because I wanted to assure and find that the dye that I have in hand is authentically natural. Because when you look at the dye powder, you really cannot make it out whether it is synthetically prepared or whether it is prepared from natural resource. So, therefore, I was looking for standards. Can I test these natural dyes to find the authenticity of it being from natural origin? However, when I did not find any standard for natural dyes, the idea of making testing protocol for natural dyes occurred to me. Way back in almost 2000, in the field laboratory at IIT Kanpur and working as an analytical chemist, I started making my own testing protocols for natural dyes. We had an array of instruments, and I started looking at analyzing these natural dyes on those instruments. Identification of natural dyes on the basis of its structure through spectroscopic methods. Looking for adulterant, usually a very serious problem with high priced natural dyes by chromatographic methods. Major challenge that became my research program's integral part. So, actually the problem came from the fact, every time a research arises either from a need or a question in the mind, and the question in the mind was that, is this indigo sample totally a bio source indigo or does it have synthetic indigo? Is this madder or rubia powder purely from madder or mangist, or has alizarin dye, synthetic dye been mixed in this? So, that was the challenge that I had in front of me, which I wanted to analyze and satisfy my own curiosity. Natural dye and its testing protocol. So, source of natural dye could be flower, bark, leaf. First we look at the solubility of the dye, then we go on very systematically to chromatography. This is based on the nature of the compound. Remember, we had taken this thin layer chromatography, gas chromatography, column chromatography, as well as liquid chromatography in a fleeting way to understand, and this is what helped us in developing the testing protocol. Then we started using spectroscopic instrument. This is based on molecular structure, where we were using the UV visible and the FTIR spectroscopy, whereas along with mass and NMR spectroscopy. Since no standards were available for natural dyes, for testing they were not available, we had to work very hard to establish each chromatographic and spectroscopic method. We repeated it several times to see the repeatability of the test and to draw inference from those test results and spectral data and chromatograms. Check its repeatability and reproducibility. By setting instruments parameter, getting third party verification for our methods for other laboratories. So, reproducibility and repeatability are very important. If I get it one time and then the second time I do not get, then this is of no consequence, because if the molecule is the same, it should give the same chromatogram, and if the procedure that I am following remains the same, that means the eluent that I am using, the conditions that I am putting on the machine are the same, and the column that I am using, then there should be, the results should be reproducible. So, getting a third party verification was the next step that we tried to do. We gave the same samples, gave them the method and asked them to repeat that method. Since no test methods for natural dyes were available so far, we started looking at two dyes very carefully. We started first developing protocol for madder and indigo. These were the most abundantly used dyes. Formulated test method for Bureau of Indian Standard by chromatography and spectroscopic analysis, and then we established this process by these two techniques repeatedly. A reliable method, chemical identification. So, first we did a TLC, then we did an FTIR and UV vis, then further we did HPLC, NMR and mass, and all the possible spectroscopic and chromatographic techniques were applied in one way or the other to get some information about the authenticity of the natural dye. UV visible analysis of dyes. When a material is illuminated by light, specific wavelengths are absorbed depending on the molecular structure present. Electrons in the ground state molecule absorbing light energy and moving to an excited state causes this. The absorption intensity depends on the wavelength, and the absorption spectrum, that is the curve measuring absorption intensity, changes accompanying wavelength changes for monochromatic light illuminating a material, is characteristic of a specific material. If there is a dye molecule, it will have certain amount of conjugation, and that we have understood. These conjugate positions will be identified by UV, because that is where the double bond of the pi bond gets excited, and absorbs light. Analysis of material based on this principle is called absorptiometry. This analysis can be used for various purposes, that is identification and quantitative analysis. This is a UV machine which we used in the laboratory and it gave very consistent result. When we took the spectrum of synthetic indigo and natural indigo, we found small changes, and that indicated that synthetic indigo is different, though slightly only. The peaks appeared at 607, whereas in natural indigo the peak appeared at 603 in the visible region, whereas in the UV region for synthetic indigo it appeared in 288 and in natural indigo it appeared at 285. When we did this repeatedly and we got the same difference, we understood that there can be a method by which we can identify synthetic indigo and natural indigo very carefully. Fourier transformed infrared studies. The infrared radiation imparts vibration to the bonds of the molecule. These bonds may comprise of functional groups. Functional groups can be identified by FTIR of purified dyed extract. Major peaks can be identified for different types of CC, CH, CO, stretching and bending vibrations. Absorption in the infrared region is due to molecular vibration of one kind or another. The spectrum is generally very complicated and contains many absorption peaks. FTIR spectrum then gives mostly the double bond and the triple bond positions, and one can get many vibrational and bending modes from which we can infer that particular functional group is present in the molecule. When we look again at the IR spectrum of natural indigo, the A, B, C, D marked on the spectrum are quite different from the spectrum that arise in the synthetic indigo. Here the A, B, C, D are slightly different, and therefore one can overlay these peaks and see that these differences are, although small, but are conspicuous enough to identify the natural indigo from the synthetic indigo. Moving on, then we used high pressure liquid chromatography, HPLC. It is a broad analytical chemistry technique used to separate compounds in a chemical mixture. These separations utilize the pressure driven flow of a mobile phase through a column packed with a stationary phase. The purpose of high performance liquid chromatography HPLC analysis of any dye is to confirm the identity of a dye and provide quantitative results, and also to monitor purity content. And this also helped us to identify if there was any adulterant in the dye. A pure dye will always give one peak or a pattern of peak, but an impure dye will have extra number of peaks. The HPLC chromatogram of alizarin and rubia. Alizarin is synthetic compound which shows only one peak, but as I told you, rubia cordifolia has purpurine, alizarin, mungicin and many other compounds in various concentrations. Therefore, they show a different peak style and design. Gas chromatography with mass spectrophotometer. Gas chromatography and mass spectrophotometer, that is GCMS, is an important detection method for natural products, providing chemical fingerprints from the peaks. Electron impact source EI and automated library searching makes chemical identification easy. A gas chromatograph serves a method to separate a mixture so that they enter the mass detector, one at a time for identification. GCMS is an essential technology in modern analytical chemistry labs. Applications include analysis and their purity. Application of GCMS includes drug detection, fire investigation, environmental analysis, explosive investigation, food and flavor analysis, and identification of unknown samples, and we explored it for dyes. Now, when lycopene, which is a dye, has a conjugated structure, is subjected to GCMS, we get a mass molecular weight, molecular iron peak at 537, and then a major peak at 444. This is, and there is a peak also at 536, which means that lycopene actually is present, and the fragmentation pattern always remains the same. There are challenges in natural dyeing, and we have been talking that these methods only help us to identify whether or not these are present in from the natural resource, because the natural resource we have even done the structure elucidation. The two main challenges in natural dyeing are wash and light fastnesses of the dyed fabric and to get good dye uptake. Lot of research has gone into this effort as the commercial market seeks best dyed fabric in all textile materials. Consumer is not going to make any compromise. They will look at a dyed fabric. Even if you and I go to a market, if it is dull looking, unevenly dyed fabric, will you or I buy that fabric? No. Or that garment? So, everything is commercial and consumer driven, and for that perfection is required. How to increase the dye adherence and how to retain the dye on the fabric are the two main issues that need to be addressed in order to improve the fastness properties. For dissemination of technology of natural dyeing, it is imperative to mitigate these challenges. If we are talking about that, yes, now that natural dyeing process technology is mature enough and we should now disseminate this technology because it is mature. Well, are we ready? Ready, because we still have two main challenges in front of us. How to improve the dye adherence, that means the color strength should be very good, the color uptake should be very good, and how to retain that color so that the wash fastness and the light fading does not take place. At least it could sustain for several wash cycles and for several hours of UV exposure. So, if we are not worried about these two aspects, we are still not ready with the dissemination of the technology. How to make natural dyes overcome this drawback? We can identify the natural dyes using all those techniques such as chromatographic techniques and spectroscopic techniques. We can identify them by HPLC, by GCMS, by TLC, and say, okay, it is a one component system, it is a two component system. We can use spectroscopic methods to identify the functional groups, and eventually with the help of mass fragmentation we can identify even the molecular structure. But these problems are quite different. Identification of its authenticity to be a natural dye is a different ball game, and overcoming this drawback of good dye uptake and fastness property is another domain. Keeping in mind the eco-friendliness of any new reagent and its compatibility with natural dyes, a lot of chemistry can be applied to enhance the wash and light fastnesses of natural dyeing. dyed fabrics using biomodants, enzymes, chitosan, and by physical methods using different types of plasma treatment, EB treatment. Different natural dyes helped us to overcome this hurdle. Among the physical methods, we used plasma and electron beam excitation for surface modification. And we have spoken quite in detail that how metal mordants, when replaced by biomodants or enzymes or plants which have metal accumulation in just the right quantity, could help. Even chitosan with turmeric could help improve the fugitiveness of turmeric dye. So, we have done a lot of experimentation and we have come up with solutions using rare earth metals in place of the toxic metal salts. Even helped us to get better dye uptake and better fastness properties. Role of textile process enhancers. Textile process enhancers improve performance during the textile treatment process. A fixation of natural dye helps to retain the dye on the fabric, as these dye fixing agents help in wet and dry processes and often enhance light fastness properties of textiles as well. They also work to avoid shade change and bleeding of dyes, especially during the first wash. And that is the reason why you would remember that your granny would tell you that please wash your your new garment in sodium chloride solution. Put some salt, common salt in the bucket and rinse it with that for the first dye. Now that is acting, that was a homely way of dye fixing, because some of the supernatant coloration which is on the upper surface of the fabric needs to get washed off and the rest of the color need not run off. For protecting that, this kind of sodium chloride solution was recommended. And similarly, we now need to look for safe textile process enhancers which can improve the performance of the dyed textile products. Use of industrial salts. In textile industry, industrial salt is used in the dyeing process of fabrics and material, such as for dyeing cotton and silk. When used in dye bath, salt causes the dye to completely penetrate the fabric, making thereby dye process easier. And we saw that how it acts as an electrolyte. It also pushes the dye molecule to the interface of the fabric from the solution, and that is how these salts play a very vital role in promoting the dyeing process. Two types of industrial salts for textile dyeing are commonly used, that is vacuum and rock salt. Both types of salt have a very high sodium chloride content and are available in different grain sizes. This dye fix is very safe, eco-friendly and readily available, and that is why as we are moving on, we are trying to understand the dissemination. We should also see every aspect, not only the quality aspect, but how to improve the challenges that the natural dyes bring with them. When we are exploring new natural dyes, then it is all the more to do a thorough study of every aspect of natural dyeing. Extraction, how can we extract it most efficiently from the plant part? We have seen many extraction techniques we have studied. Which one is most apt for it? Then how to prepare, what is the metal salt compatibility with that dye, that kind of test, because we have already done that exercise for enzyme, and we have seen that enzyme definitely have a lock and key arrangement. Not every dye will be compatible with every enzyme. So, which enzyme is specifically better? Similarly, which mordant is specifically better for that dye? That exercise we have to do. Once we have established all these preliminary information, then it is ready for dissemination. And definitely how to have good dye uptake and how to have good color fastnesses are also two aspects which need to be kept in mind, and how to retain this color on the fabric with the use of industrial salts and particularly sodium chloride. Use of dye fixers. Further, dye fixers help in the migration of dyes during wet storage. Apart from this, there are wash off agents that promote the removal of unfixed natural dye and have sequestrating effect on calcium and magnesium ions of the hard water. Conventionally, saturated solution of sodium chloride was used as dye fixer, and now of course soda ash, sodium carbonate is prevalent in its use. So, whether we use sodium chloride or sodium carbonate, these are all safe chemicals and they are naturally available from rock salt and other sources, and they can be used as dye fixers. Dye fixer is a chemical called sodium carbonate or soda ash. It is the most essential chemical in our dyeing process because it causes the chemical reaction that makes these dyes become part of the fabric. The impregnation process is enhanced by this dye fixer, which is a very ordinary chemical called harmless chemical called soda ash. These dyes will not work without the use of dye fixer. Fixing agent is to be applied to dyed fabric to fix the unfixed dye stuff on the fabric, because when we are dyeing there is some supernatant or superficial dye which is sitting, which has not impregnated into the fibers, and this dye needs to be washed off. Only the dye that has impregnated needs to be fixed. It improves wet color fastness and fabric quality. Use of biomordants in place of metal mordants. In this industrial dissemination technology, we are promoting mostly use of biomordants, because in order to make the dyeing process, natural dyeing process sustainable and eco-friendly, instead of metal mordants we are recommending biomordants, and got almost competitive results in terms of wash and light fastness, and this paper has been really cited very heavily. Another plant extract has inherent metal such as aluminum or any such transition metal can also be used as dye during the dye extraction process, and we use urea acuminata and pastia, pyrus pastia, which had aluminum and copper respectively in small quantities, yet it was enough to do the mordanting step, and we call them biomordants, because these plants were co-extracted with the natural dye yielding plant, and they were then used for dyeing. This helped us to completely eliminate metal mordanting step in natural dyeing process. At the same time, we got very good wash and light fastnesses for the dyed fabric. After all, why were we using metal mordant? The purpose of using metal mordants like copper, chromium, iron, alum and tin was to get good dye adherence and good fastness, and if we can achieve that with metal mordants, we have actually won the case. Use of reagents like natural or which are from natural origin such as chitosan. We have proven that fugitive natural dye such as curcuma, which has curcumin as the main colorant molecule, had very poor wash and light fastnesses. It was in the order of 2 and 1 and that kind of rating. However, the availability of the hue color of curcuma always attracted the dyers. And if you would remember that during earlier times, for the pujaris, the dhoti was dyed in haldi, and that is curcuma dye. But it would get washed off in 1 or 2 washes. Now, when this curcuma dye was combined with chitosan, which is also from natural origin, the same dye had shown very improved wash and light fastnesses. The novel natural modern chitosan with different concentration, 10% and 20% weight of the fiber, was applied on cotton, and fabric was printed with natural dyes such as catechu, turmeric, marigold, using screen printing as well. So, not only we proved that chitosan is good for dyeing, chitosan is also good for printing. We then moved on to introduce enzymes in natural dyeing. It was for the first time that we were the first ones to use several enzymes in natural dyeing processes. The compatibility of each natural dye to different enzyme is like a lock and key matching factor. However, the results are very good in terms of wash and light fastnesses of the dyed fabric in this case. So, after all, if we can find a mordant, a bridging head which can replace toxic metal salts, it serves the purpose, whether it is enzyme, whether it is bioenzyme, whether it is biomordants, anything and everything that works to restore the color, to keep the wash fastness and light fastness good, is what is required in natural dyeing. The effectiveness of 3 enzymes, that is the combination enzyme protease amylase, diesterase and lipase, were used and determined. The enzymatic treatment gave cotton and silk rapid dye adsorption kinetics and total higher adsorption than untreated samples for all the 3 dyes, and it was almost a result which was very rewarding, and even this paper was very well cited in literature where natural dyeing papers are published. We have also introduced the use of sonicator. For the first time, ultrasound waves were used in dyeing process, and we have observed that it can be scaled up, and that the dye uptake and dye adherence were markedly enhanced. Indirectly, it helped to improve wash and light fastnesses too, and the dye adherence was greatly enhanced. Shankar and Vankar, in the year 2005, we published this paper, and it is very well cited. Generally, the sonochemical activity arises mainly from acoustic cavitation in liquid media. The acoustic cavitation occurring near a solid surface of the fabric will generate microjets. The microjet effect facilitates the liquid to move with a high velocity, caused increased diffusion of the solute inside the pores of the fabric. In the fabric, localized temperature rise and swelling effects due to ultrasound may improve the diffusion. This is an acoustic streaming effect associated with the stable cavitation responsible for the enhanced molecular motion and stirring effect of ultrasound. Stirring action also reduces the concentration gradient in the immediate neighborhood, and therefore there is a good dye uptake which is enhanced by ultrasound waves, and this cause good dye uptake is usually associated with good fastness property, because this is not on the surface. These dyes are penetrating into the fiber because of improved diffusion, and that is what was beneficial. Now, these technologies we actually disseminated at many places, and now the natural dye industry is following our technologies. Standard natural dyeing and dye testing protocols are done for the following quality management: in Khadi and Village Industry Commission, that is KVIC, Gandhi Ashram, Barabanki, Meerut, Akbarpur, Maghar, we followed this KVIC institutes where we did the dissemination of the natural dyeing technology. At Avni, it is an NGO in Uttarakhand, we did there. With NIG Germany, we did the dissemination of natural dye technology. With Ama Herbal in Lucknow, we gave some of our results to them so that they can also use it as a propagation for their products. Then in Textured Jersey, Sri Lanka, and Ocean Lanka at Sri Lanka, we did the dissemination. Now we are ready for dissemination of this technology. We have come a long way. We have proven that natural dyeing and innovative dyeing techniques are not just restricted or feasible at the laboratory scale. They can be scaled up, because we scaled it up in all these KVIC organization in Gandhi Ashram, Barabanki, Meerut and Akbarpur, and we showed that the existing infrastructure could be used. No new method or no new dyeing machine was actually required. Whatever was available with them, we tried to do the dyeing with their existing facility, and by doing so we were able to achieve the same fastness properties, the evenness in bulk dyeing, and the meters and meters of dyed fabric were produced from khadi silk and khadi cotton. At Avni, we tried to concentrate on the rubbing fastness of in natural indigo and testing various samples for their dye content in their different produces of indigo leaves, because there was a seasonal variation that we noticed. So, at every level we are trying to cooperate with natural dyers, and whoever has whatever problem, either of color fastness, either of color adherence, or identification of the authentic natural dye, presence of any adulterant, we are trying to help the industry by giving them solutions. And remember, in one of the slides I had shown that we have come up with 10 natural dye standard publication with the help of Bureau of Indian Standards, and we were able to then publish them in the year 2019 and to 2020. So, in summation, I would say that natural dye process is now mature enough for the dissemination, and a lot of drawbacks which were earlier witnessed by natural dyers who were not doing it in a very standardized manners have been overcome. This natural dyeing process is something that should be now promoted more and more, because it is sustainable, because it is having least amount of environmental impact. And looking at all the brands which are in textile production, they are all switching to natural colorants for the simple reason that they have also realized, and the quality management system and the ISOs have been pressurizing to follow a safer and a more productive kind of dye technology to use printing or dyeing the garments and fabrics. So with this, we have come to an end of this lecture, and thank you.
Hi, I'm Chitwan Lalji, a PhD student of Health Economics under the supervision of Dr. Debayan Pakrashi from the Department of Humanities and Social Sciences, IIT Kanpur. In one of my essays, I'm interested in understanding the relationship between consumption of fruits and vegetables and various health indicators. Health indicators, both subjective and objective health indicators like mental health, self-assessed health, various measures of blood pressure and various measures of cholesterol. Measures of blood pressure like systolic and diastolic BP. You have your incidence of high BP, MAP, and incidence of high MAP. And as far as cholesterol is concerned, I have tried to concentrate more on total cholesterol, good cholesterol, and incidence of high cholesterol. Now, before I go on to what have been my major contributions and various policy implications, I would like to briefly tell you about the policy initiatives of WHO and various countries. The WHO, that is the World Health Organization, it started with a campaign of 5 a day. That is, you should have 5 portions of fruits and vegetables per day. That would be approximately, you could say, 400 grams of fruits and vegetables. Now, a portion, before we go further, I'll just tell you what exactly is a portion. One portion is equivalent to a medium-sized apple, or one small glass of fruit juice, which is approximately 150 milliliters, and maybe 3 teaspoons of vegetables. So, the WHO went with a 5 a day campaign, which was further taken up by various countries. Countries like UK, Netherlands, Germany, Norway, they adopted the 5 a day policy, while some went for expansionary dietary policies like France, Australia, Canada, Denmark. So, for example, Australia, it went for 2+5 policy, in which it said that you should consume 2 portions of fruits and 5 portions of vegetables per day. And USA went for a policy of fruits and vegetables more matters. That is, you must consume more and more fruits and vegetables. Now, irrespective of these expansionary dietary policies and dietary propagations, it has been found that only 28% of women and 25% of men, they actually meet the recommended dietary norms of 5 a day portion. So, the major contribution of my work is firstly to find an association between fruits and vegetables, whether there exists a relationship between fruits and vegetables and health indicators, and if they exist, whether due to heterogeneity in the data. So, I will be doing it according to age, by gender, and by your weight. So, apart from that, I will go for policy recommendations, in which I am basically studying how much fruits and vegetables matter. Apart from that, which type matters more. So, for that, I have taken data from the Health Survey of England. Health Survey of England is an annual survey which takes data, which conducts information regularly on demographic and socioeconomic characteristics. You have your lifestyle behaviors like an individual smokes or doesn't smoke, alcohol consumption, you have your sedentary and physical activities, and you have various health indicators also which have been collected. Before I go on to what exactly is my research, I would like to concentrate more on fruits and vegetables, like what kind of questions were asked in the survey. Questions like, what kind of fresh fruit do you eat? Did you eat any dried fruit yesterday? Don't count dried fruits in cereals, cakes. Apart from that, for vegetables, they asked how many tablespoons of vegetables did you eat yesterday? So, approximately after this whole survey was conducted, data was converted into portions of fruits, and like for example, 3 tablespoons of vegetables is equivalent to 1 portion. So, data was converted and provided to the users, that is us, from the UK Data Health Survey. So, the major contributions of my paper is that I found a strong negative association between intake of fruits and self-assessed health, then various measures of blood pressure like mean arterial pressure, high blood pressure, systolic and diastolic BP, and your total cholesterol. Apart from that, I have found a strong positive association between consumption of vegetables and good cholesterol. So, it is recommended in a way that if you want to control your blood pressure, you must consume more and more fruits. And as far as vegetables are concerned, they impact your good cholesterol. Apart from that, I went in for a falsification test. A falsification test is basically conducted to know whether the model that you have adopted and the conclusions that you are drawing are not spurious. So, if a falsification test is done to know, in a way it is tested by seeing an indicator, a health indicator which is not being impacted by your consumption of fruits and vegetables, and then we see whether there is significant result or not. If there is no significant result, that means your model is good and your results are non-spurious. So what we did is, for falsification test, we took ear complaints and infectious diseases. Now ear complaints, like if you are deaf since birth or you have some kind of imbalance, body imbalance, that is not being impacted by your consumption of fruits and vegetables, and we did find insignificant results. Apart from that, infectious diseases like HIV, AIDS, etc., we found similar insignificant results, indicating that our results are not non-spurious. Apart from that, we went, since there was a lot of heterogeneity in the data, like by gender, by age and by weight, we did the regression analysis. We found results which stated that as far as fruits are concerned, it impacts a male's health more than a female's health. So it is basically said a man should consume more fruits to impact his health, whereas as far as vegetables are concerned, they impact a women's health more. But this has been only seen as far as cholesterol is concerned, the various measures of cholesterol like total cholesterol, good cholesterol and your incidence of getting high cholesterol. Now after this, we went in for a policy implication, and in the policy implication we tried to find two policy implications: what matters and exactly how much portion matters. So as far as how much portion matters, we have found that on an average 5 or more portions of fruits impact your overall health, that is your self-assessed health, your MAP, your incidence of high MAP and incidence of high BP. But if you want to have a good mental health, so you can optimize your mental health by consuming 3 or 4 portions of fruits as well. And similarly, as far as self-assessed health and total cholesterol is concerned, an individual must consume 4 to 5 portions to optimally have the impact of consumption of fruits. Apart from that, vegetables have had a very little impact on your health. It only impacts your incidence of getting high MAP and high BP, and it's seen that only it impacts when you consume 5 or more portions of fruits. So an optimum consumption of 5 or more portions of fruits and vegetables are recommended, but fruits have a more impact on your overall health, on various measures like self-assessed health, mental health, your various measures of blood pressure and various cholesterol levels. Another thing that we find is which type of fruit matters. It has been seen that all size fruits, they impact your self-assessed health, your systolic and diastolic blood pressure, your mean arterial pressure, your high BP and incidence of getting high MAP and high cholesterol. But we find that as far as frozen fruits or canned fruits are concerned, they help in regulating your incidence of getting high MAP or high BP, but it has a trade-off. That means there is something negative happening. It reduces the good cholesterol in your body. Apart from this, if you have an incidence of getting high cholesterol, it is recommended that you must consume fruit juices because it has an impact in reducing your probability of getting high cholesterol. And dried fruits, they impact your self-assessed health. As far as vegetables are concerned, very little impact has been seen. It has only been seen in case of portion of salads and its association with self-assessed health. Another thing that they have seen is vegetables in composite, they have an association with good cholesterol. So overall, my research basically says that there is an association between consumption of fruits and vegetables and various health indicators, and it is highly recommended that an individual, in order to be healthy, must consume 5 or more portions of fruits and 5 or more portions of vegetables per day. But fruits have a more impact on your overall health. Apart from that, all size fruits, they have a better impact on your overall health, your mental health, various measures of blood pressure and cholesterol. So, thank you.